So good morning everyone. We have started unit 6 of cryptography and network security and we have seen the introduction. As I already told you people, unit 6 is network security part 2, unit 5 is network security part 1. So in part 1 what we have seen? In part 1 we have seen what are the protocols, what are the layers we have. So in part 2 what we are going to discuss is, so only two topics in part 2, security at network layer. This is the topic we want to discuss. In that only two topics we have, IP security and system security. I wanted to tell you what system security is first. So what is system security? In this we have to discuss what is firewall, what is malicious software or program, and finally intrusion detection systems, intruders. So we are in unit 6 of cryptography and network security. Unit 6 is nothing but network security part 2. Obviously network security part 2 is nothing but providing security to the network layer. As a part of that we will discuss about IP security, Internet Protocol Security. So Internet Protocol Security is topic 1, and next one is system security. This system security can also be called as web security. We can call it web security, we can call it internet security, we can call it system security also. So what is system security? You have to know what is a firewall, you have to know what is a malicious software or malicious program, then you have to know who are intruders and what is intrusion detection system. IDS means intrusion detection system. If you study these three topics, it is nothing but web security or system security. So what is a firewall, what is malicious software, what is intrusion detection systems. So first we will see what is internet protocol security. First we will see what is internet protocol security, IPsec. Then we will see system security, nothing but these three topics: firewall, malicious software, which is also called as malicious program, and the last one is intrusion detection systems. So first let us see what is IP security. So first let us see what is IP security. So obviously we are talking about network layer. As I already told you, in third year you have the subject like computer networks. In computer networks, very first topic is OSI layers. In OSI layers you will have this network layer. Okay, so now if you want to provide security for that network layer, you need the concept or you need the protocol like IPsec. So IPsec can be a protocol, IPsec can be a service, IPsec can be a suite. So I have computer networks topic. In computer networks I have OSI layers. In OSI layers I have different layers like application layer, session layer, presentation layer, network layer, transport layer, data link layer and physical layer. Now I want to provide security for network layer. To provide security for network layer, I am using one protocol like IPsec, which is nothing but Internet Protocol. Internet Protocol Security. So first we will see what is IPsec, what is IPsec architecture, what are the IPsec benefits, what are the IPsec applications, why we are using IPsec, all these things we will see. So as a part of that, what is the first thing? As a part of that you have to know what is IP security overview. Overall what is IP security. So you can see here, IP security is an Internet Engineering Task Force standard suite. As I already told you, IPsec is a group of protocols. IPsec is group of protocols. So what is this group of protocols? Internet Engineering Task Force is a standard. It came up with a group of protocols, nothing but IPsec suite. So what it will do? It will provide authentication, integrity, confidentiality. In unit 1 we have studied about security goals. What are the three security goals we have? Integrity, confidentiality, authentication. So that security goals are achieved by IPsec in network layer. So authentication, integrity, confidentiality are provided by IPsec in network layer. What I wanted to tell you, I have system A in network A and I have network B in that system B. Now A want to transfer data to B. A is a system in network A. B is a system in network B. Now A want to transfer the data to B. How it will transfer? It will transfer in the form of packets. It will transfer in the form of packets. One system in one network will transfer packet to other system in other network in the form of data in the form of packets. Now to provide security for this data which is transferred from system A to system B, we are using IPsec because all this is happening in network layer. Transfer of data from one system to transfer of data to other system is happened in network layer in the form of packets. So now I am using IPsec protocol, which is nothing but a group of protocols or a suite for providing security to the data which is transferred in the form of packets from one network to another network. So IPsec is used to provide security for the data which is transferred in the form of packets from one network to another network. So what is the basic thing you want to know? IPsec is a group of protocols, or IPsec is a standard, or IPsec is a suite. IPsec is nothing but internet protocol security. So what it will do? It will provide authentication, integrity, confidentiality. What are authentication, integrity, confidentiality? Security goals we discussed in unit 1 achieved by IPsec. So what it will do? We have n number of systems in network A. We have n number of systems in network B also. Network is nothing but group of computers that you already know. Group of systems or group of computers which are going to share a common resource. While starting unit 1, cryptography network security subject itself has the word network, and there I told you the network definition. Our subject cryptography and network security, it itself has a network definition. Network is nothing but group of systems interconnected. Group of systems interconnected to share a common physical resource. Group of systems interconnected to share a common physical resource. So what I mean by network here? Network A will have a group of systems. Network B also will have a group of systems. So what is the second point that IPsec is going to provide? IPsec will provide security for the data which is transferred in the form of packets from one network to another network. So see here. So first thing, Internet Engineering Task Force Standard Suite of Protocols, nothing but IPsec. IPsec is used to provide authentication, integrity, confidentiality. Second point. Third point, a packet is nothing but data in the form of a bundle, and IPsec is used to provide security for bundle of data. Bundle of data, nothing but packet. So packet is nothing but a bundle of data or a piece of data. Now that security is provided for the bundle of data or piece of data. That is the third point. And see finally, IPsec protects against possible security exposures by protecting data while in transit. This is what I have told you now. What these people are saying, IPsec will provide security. For what it will provide security? For data. Data is in the form of packets. Where all this is happening? When data is transferring from one network to another network, from one system to another system. Last point is same here. IPsec protects against the possible security exposures. It will protect us from when it will protect while data is in transit. While data is in transit is nothing but network to network there can be a communication. System to system there can be a communication. Or network to system also we can have the communication. If you want to transfer the data from one network to another network, or if you want to transfer the data from one system to another system, that data is transferred in the form of packet, and this IPsec will provide security for the data in the form of packets by providing authentication, integrity, confidentiality. Simple. So the next one, what are the IPsec features? We already know it is the most, IPsec is the most secure method. It is commercially used. It is designed to follow some principles like authentication, integrity, confidentiality. So as I already told you, IP security features. What are the IP security features? 3 different IP security features we have. Authentication, integrity, confidentiality. These are the 3 different features of IP security. So as discussed before, IP security is a secure method. IP security is commercially used method. What are the 3 features we have? Authentication, integrity and confidentiality. So we will see one by one. What is authentication? Authentication is nothing but verifying that packet is received actually from the claimed sender. We have network A. Here we have one sender also. So we have network B. Here we have receiver. So authentication is nothing but verifying whether the packet is sent by the claimed sender or not. Sender A want to send packet to receiver B. Okay, if you want to understand clearly, Jim is the sender. Jim is in network A. Bob is the receiver. Bob is in network B. Now Jim want to send a message to Bob. What is authentication? Verifying whether Jim only sent this message or not. That is authentication. Sender will be in one network, receiver will be in another network. These two, sender and receiver, should communicate in the form of packets, in the form of data or message. While communicating, authentication is nothing but verifying whether this sender only sent that data or not. Same way, Jim is the sender, Bob is the receiver. Those both are in different networks. When Jim want to communicate with Bob in the form of message, this message also treated as packet only. Now what I wanted to know? I wanted to know whether this message was sent by Jim or not. That is authentication. Particular sender only sent that message. Authentication. I want to send you CNS material. I am the sender, you people are the receivers. Authentication is nothing but you should know whether CNS madam only sent that CNS material. Who is dealing that subject? Particular teacher only sending that message. Authentication. What is integrity? Integrity is nothing but you are making sure that that message contents did not change. Sender only sent CNS material. Authentication. Content in the CNS material does not change. Integrity. So sender and receiver can be in same network. Sender and receiver can be in different networks, but sender and receiver should communicate. They are communicating in the form of packets or messages, whatever it may be. While communicating, we need to provide authentication, integrity, confidentiality. These are achieved by IPsec protocol suite. And what I wanted to tell you, authentication is nothing but genuine sender is only sending that data packet. Integrity is nothing but you should believe that contents of that data is not changed. Means I want to send you CNS material. You believe that CNS material contents does not change it by any other. Integrity. Particular sender, genuine sender is only sending the data to receiver. Authentication. Contents of the material or contents of the data or contents of the packet does not change. Integrity. And finally, confidentiality is nothing but the data is encrypted. So I wanted to tell you, this is network A. This is network B. So in network A we have so many systems. In network B also we have so many systems, so many people. Now data is transferred in the form of packets from network A to network B. So in network A we have sender. In network B we have receiver. So network A with group of systems, network B with group of systems, sender in network A, receiver in network B. Data is transferred between these two networks in the form of packets. Now I need authentication, integrity, confidentiality. Confidentiality is nothing but believing this data is encrypted. So confidentiality is nothing but believing these packets are encrypted. Integrity is nothing but believing the contents of the data does not change. Authentication is nothing but verifying whether this sender only sent this packet or not. Whether the sender only sent the packet or not. Verification is authentication. Believing that, making sure that contents of the data doesn't change. Integrity. Believing that all the data is encrypted properly. Confidentiality. So these three are the features of IPsec and that are achieved. These three are the features of IPsec and that are achieved. So next one, IPsec elements. What are the elements of IPsec? We have, see here, three elements we have. Encapsulating security payload, ESP. Authentication header. First one is encapsulating security payload. Second one is authentication header, AH. Third one is internet key exchange, IKE. So IPsec elements is our next topic. We have three types of IPsec elements. Encapsulating security payload, first one. Authentication header, second one. Key exchange, internet key exchange, third one. Okay? This internet key exchange is also called as Security Association Management, SA. So what are the elements of IPsec? We have three different elements of IPsec. First one is encapsulating security payload. Second one is authentication header. Third one is internet key exchange. This internet key exchange sometimes also called as security association. What these elements will do? Confidentiality, authentication, integrity is provided by encapsulating security payload. Authentication and integrity provided by authentication header. So what key exchange will do, we will see later. So we have three elements. First element is encapsulating security payload. It will provide confidentiality, authentication, integrity, three features. Second one is authentication header. It will provide only authentication and integrity. Confidentiality is not matter here. Third one is key exchange. What that will do, we will see in the next slide. So this is the overall scenario of IPsec. See, you can see here, we have IPsec header, we have IPsec payload. So using these may be routers. In a network, we can use routers for data transfer. So packet is divided into IPsec header and IPsec payload. See, you can see the system here. So from here to we need to transfer data from another system. So for that we are using some private networks, public networks, routers. We are having that packet in the form of IP header and IP payload. So IP header, IP payload. So this packet contains two parts, IP header and IP payload. So this is system A. We need to send data to system B. In between we can use routers also. We can have any number of networks in between. So we can take the help of internet also. This is internet. For transferring data we can take the help of internet. So from system A to we need to send data to system B. For that we can take the help of internet. We can take the help of routers also. But how this IP packet is divided? See, IP packet is divided into IP headers and IP payloads. So this is the overall scenario. IP header and IP payload. This is the overall scenario. You can use the help of routers. You can take the help of internet. You can transfer the data between two systems with the help of internet. But the thing is, you should divide that packet into IP header and IP payload. What is IP header? What is IP payload? We will see. But this is the overall scenario of IP security. So next one, what are the applications of IP security? So as of now what we told, IP security is a protocol suite. It will provide authentication, integrity, confidentiality. It is a commercial project. It is commercially used. It is highest secure method. Then we told that it has the elements like encapsulating security payload, authentication header and key exchange. Then we also know that it has some advantages like transferring data between two networks securely. Then finally, applications of IP security is nothing but where we are going to use this IP security. Applications is nothing but where you are going to use this IP security. So where you can use between two LANs. You can use between two WANs also. Local area network and wide area network. If you remember computer networks, in computer networks you will have local area networks, wide area networks, metropolitan area networks, like that. So this IP security can be used between two LANs, nothing but local area networks. Can be used between two WANs, wide area networks. So first important point is applications is nothing but what are the uses. So what are the uses of IP security? So we have many uses. See here, we can provide secure remote access over the internet. Providing secure remote access over the internet. Secure branch office connectivity over the internet. Establishing extranet and intranet connectivity with partners. Enhancing electronic security. So what I wanted to tell you is, we can use IP security protocol between two LANs. We can use it in the form of extranet or intranet. You know what is extranet and intranet. So within the organization you can use IPsec. Outside the organization you can use IPsec. Between two different organizations also you can use IPsec. This is what I wanted to tell you. Over the internet, if you want to transfer data, IPsec is useful. Within the organization intranet, IPsec is useful. Between two different organizations extranet, IPsec is useful. For remote access, IPsec is useful. For commercial purposes, IPsec is useful. So all this is nothing but what is the summary of all these points is, IPsec is commercially used. IPsec is highest security provider. IPsec is used over the world. IPsec can be used to establish the connection between two networks. IPsec can be used to establish the connection between two organizations. IPsec can be used to establish the connection with remote access organizations. So the overall summary is, in internet, intranet, extranet. For remote access between organizations. For security regarding network layer, IP security is used. So next one is services. What are the services provided by IP security? So see, in first unit we have discussed about security services. Same security services only again we will see here, but all these security services are supplied by IP security protocol. So see here, IP security will provide some services at IP layer, nothing but network layer. So why? What are the services and why it is providing? Because it have encapsulating security payload and authentication header. See, we have encapsulating security payload, we have authentication header. These two are elements of IPsec, and we have key exchange also. So these three are elements of IPsec. So elements of IPsec will provide some services of IP security. So IP security will provide some services at IP layer. IP layer is nothing but network layer. How can it provide these services? Because it has three elements. The three elements are nothing but encapsulating security payload, authentication header and key exchange. With the help of these, what services it is going to provide? Access control, connectionless integrity, data origin authentication, rejection of replayed packets, confidentiality, limited traffic flow confidentiality. In unit 1 we have already discussed about what are the security services. Access control is nothing but giving permissions. Connectionless integrity is nothing but you are making sure content is not changed. Data origin authentication is nothing but verifying the sender. Rejection of replayed packets is nothing but eliminating duplications, redundancy, reducing the redundancy. Confidentiality is nothing but you are ensuring every bit of data. Limited traffic flow confidentiality is nothing but maintaining the overflow and underflow at receiver. So first one is access control. So you are giving permissions to the user. Second one is connectionless integrity. Means sender and receiver are in the wireless connection and we are ensuring that data is not modified. Third one is data origin authentication. Where the data will get origin? Near the sender. Data origin authentication is nothing but verifying the sender. Rejection of replayed packets. Rejection of replayed packets is nothing but eliminating the duplication, eliminating the redundancy, eliminating the duplicate packets. Confidentiality nothing but ensuring that every bit of data is encrypted. Limited traffic flow is nothing but making sure that a receiver is not overflow or underflow. So I wanted to tell you. So see here, IP security will provide some services. It is going to provide that services with the help of three elements: authentication header, encapsulating security payload, and key exchange. Now, what services it will provide? Access control. Nothing but giving read, write, append permissions to the user. Connectionless integrity. Integrity is nothing but making sure content of the data is not changed. Making sure content of the data is not changed. Data origin authentication. Nothing but where the data origin will happen? Near the sender, data origin will happen. So sender authentication is nothing but verifying whether the sender is genuine or not, whether the sender is real sender or not. Next one, rejection of replayed packets. Nothing but eliminating the duplication, eliminating the redundancy, sending one packet only one time. So next one, confidentiality. Confidentiality is nothing but creating a thought that every bit of the data is encrypted. Last one is limited traffic flow confidentiality. Limited traffic flow. Nothing but when we have sender and receiver, we should not overflow the receiver or we should not underflow the receiver. How many packets the receiver can receive, that many packets only we should send. If I can give you only 6 unit materials, I should give you only 6 unit materials. That is correct flow. If I give 10 unit materials, overflow. If I give only 3 unit materials, underflow. So receiver should always be in a flow. There should not be overflow, there should not be underflow. Limited traffic flow confidentiality, nothing but how many packets receiver can receive, sender should send only that many packets. So these are the services provided by IP security. So we will see. So as I already told you, authentication header, encapsulating security payload will provide these services. First service is access control. Second one is connectionless integrity. Third one is data origin authentication. Fourth one is rejection of replayed packets. Fifth one is confidentiality. Sixth one is limited traffic flow confidentiality. These are the services provided by IP security. Now, I said authentication header and encapsulation security payload are responsible for these services. So see, access control is provided by both authentication header and encapsulation security payload. Connectionless integrity is only provided by authentication header. Data origin authentication is only provided by authentication header. Rejection of replayed packets is provided by both authentication header and encapsulating security payload. Confidentiality is provided by only encapsulation payload. Limited traffic flow confidentiality is provided by only encapsulating security payload. So, 4 services are provided by authentication header. 4 services are provided by encapsulating security payload. So, what we are doing? We are integrating this authentication header and encapsulating security payload in IPsec so that all the services we can get. So, you can see here, if you integrate encapsulating security payload with authentication, you can get all the 6 services. So, we have some services. These services are provided by IP security. It can provide that services with the help of authentication header and encapsulation security payload. Only 4 services are provided by authentication header. 4 services are provided by encapsulating security payload. So, to get all the services, we are integrating encapsulating security payload and authentication header in IPsec so that we can get all the 6 services. So these are the services provided by the elements. So the next one, benefits. What are the advantages of IP security? So what are the advantages of IP security? See here, IP security is implemented in a firewall. First advantage. In the next class we will discuss what is the firewall. But IP security is implemented in firewall to provide strong security in companies or work groups. In a company or in a work group, to provide the strong security, IP security is implemented in a firewall. What is the firewall? We will discuss in the next class. So to regulate the traffic in company it is used. IP security is resistant to firewall. So to regulate the traffic, first point, IP security is used in firewall. IP security is used in companies to regulate the traffic. IP security in a firewall is resistant to all the dangers. So IP security will present below the TCP and UDP. So TCP and UDP, what is TCP and UDP? Already know. Transmission control protocol, user datagram protocol, transport layer protocols. So transport layer protocols we have two, TCP and UDP. IP security will be helpful to them also. So it can be implemented in firewalls. It is used to regulate the traffic. It is resistant to all the dangers that came with firewalls. Then IP security will be transparent to end users. Then IP security can be used and implemented in end systems. IP security will be present below the TCP and UDP. So many benefits we have regarding internet protocol security, like authentication, confidentiality, integrity, like having transparency to the end users. We can communicate in the form of packets securely. Many benefits we have. But what are the add-on benefits? Add-on benefits is nothing but it is implemented in firewall. It is used to regulate the traffic in companies. It is transparent to end users. It is resistant to all the attacks in the firewalls, and it will be helpful to TCP and UDP. Advantages, benefits are same. Applications are nothing but applications we got from these benefits only. So till now what we have seen? So what is an overview of IP security? What are the features? What are the elements? What is the structure? What are the applications? What are the services? What are the benefits? So now, what is the architecture? So see here, encapsulating security payload, internet key exchange, authentication header. If we mix these three, that is the architecture of IPsec. This is IPsec security policy. From IPsec security policy, we have three elements: encapsulating security payload, internet key exchange, authentication header. So these three are nothing but architecture of IPsec. So simple architecture, we don't have any big things in this. As we already know, encapsulating security payload, internet key exchange and authentication header. So these three are the architectural elements. Now what I wanted to tell you is, you can see here a computer, that is system A, and you can see one more thing here, that is system B. System A and system B are in communication with the help of routers. This communication can happen in transport layer, can happen in network layer. While happening in network layer, we have two different modes: transport mode, tunnel mode. So architecture of IPsec is nothing but three elements: encapsulating security payload, authentication header, internet key exchange. While we are transferring the packets, while we are transferring the data in the form of packets in network layer using IPsec, we have two modes: transport mode and tunnel mode. We will see what transport mode and what tunnel mode is. So you can see here, first one is transport mode, second one is tunnel mode. So what is happening in transport mode and tunnel mode is, transport mode is used for end-to-end communication between two hosts. Means I have host A, I have host B. End-to-end communication. End-to-end system communication can be happened in transport mode. See, transport mode will generally look after payload of IP. So while telling about the structure, while telling about the overall scenario of IP security, I told you IP header, IP payload. So this transport mode will only look after IP payload. So in the general scenario of IPsec, we have seen IP header and IP payload. Now what transport mode will do? It will do end-to-end communication between the host. It will encrypt, it will transfer data, but only thing is, it will only look after IP payload. So what tunnel mode will do? Tunnel mode will look after entire thing, like IP header and IP payload. So I wanted to tell you, IP packet is divided into IP header and IP payload. So the transmission between two networks, the transmission of data in the form of packets between two organizations or between two networks can be in the form of transport mode or tunnel mode. You can transfer the data in the form of transport mode, you can transfer the data in the form of tunnel mode. but we are expecting an end-to-end communication in transport mode, and it will only look after IP payload. But tunnel mode will look after entire this IP header and IP payload. Only the difference is that point. So we want to transfer data in the form of packets. We are talking about network layer. We know all this is happening because of IP security, and we can transfer this data in the form of two modes: transport mode and tunnel mode. What is the difference? In tunnel mode only we concentrate on IP payload. In transport mode we concentrate only on IP payload. In tunnel mode we concentrate on both IP payload and IP header. Simple. So the next one, our important thing, authentication header, AH. So what is authentication header in IPsec? It is used to provide integrity and authentication. So data integrity is nothing but you are ensuring there is no changes in that data. Authentication is nothing but you are verifying whether the genuine sender is sent or not. So this authentication is based on message authentication code. Authentication is based on message authentication code MAC, which is nothing but sender and receiver will exchange a secret key. So encapsulating security payload, authentication header, key exchange. These three are the elements of IP security. In that, first one is authentication header. So what this authentication header will do? Authentication header will provide integrity and authentication. What is integrity? Believing that there is no change in data content. What is authentication? Verifying whether the sender is genuine or not. Then what authentication header will do? Authentication header is based on MAC, message authentication code. What do you mean by message authentication code? Sender and receiver should transfer a secret key. Sender and receiver should transfer a secret key. That secret key is nothing but message authentication code. Two communication parties is nothing but sender and receiver. Sender and receiver are called as two communication parties. The two communication parties should exchange a secret key, nothing but message authentication code. This authentication header is based on message authentication code only. So we will see. So this is the structure of authentication header. So we have 32 bits, means 0 to 31. What is the size of authentication header? 32 bits. So 0 to 31. So what are the parts we have? Next header, payload length, reserved bits, security parameters index SPI, security parameters index SPI, sequence number, authentication data. So see here, next header is 8 bits, payload length, reserved bits are 16 bits, security parameter index is 32 bits, sequence number is 32 bits, authentication data is variable, means the size is not fixed. So what are the parts we have in this? Next header, 8 bits, payload length, 32 words, reserved bits, 16 bits for future. For future we are reserving some bits called as reserved bits, which is 16 bits. 16 bits we are reserving for future. Security parameter index SPI. For this security parameter index is for security association. As I told you before, see here I told you what is security association, what is key management and what is security association. For that security association here we have 32 bits. Security parameter index SPI is nothing but security association, 32 bits we reserved for that. 8 bits for next header, 8 bits for payload length, 16 bits for reserved, 32 bits for security association, sequence number 32 bits, authentication data which is variable, means size is not fixed. So exchanging the MAC will happen here. Exchanging of MAC nothing but message authentication code will happen in authentication data. So this is the structure of authentication header. So next one is encapsulating security payload. See, encapsulating security payload size also 32 bits only. Encapsulating security payload also 32 bits only, from 0 to 31. So what parts we have? security parameter index SPI 32 bits, sequence number 32 bits, payload data, padding, pad length, next header, authentication data. So authentication data, next header, pad length, padding, payload data, sequence number, security parameter index. This is for providing all confidentiality, integrity, authentication. So see, first one is security parameter index 32 bits for security association. Sequence number 32 bits to store all the sequence numbers. Payload data, as I already told you, it will take care of both IP header and IP payload also. Next one is padding. Pad length 8 bits, next header 8 bits, and to exchange a MAC authentication data variable. So this is the structure of encapsulating security payload. MAC address is exchanged in authentication data, which size is variable. So we are talking about payload data also. We are concentrating not only on header data, we are concentrating on payload data also. So 32 bits are divided into many parts for having sequence number, for having security association, for concentrating on payload, for storing padding bits. Padding is nothing but add-on bits. Add-on bits. And for length and for next header. And finally for exchanging MAC also we have authentication data. So this is the encapsulating security payload. So next one is key management. As I already told you, encapsulating security payload, authentication header, internet key exchange. This internet key exchange is for performing security association and key management. Now you people will understand. IP security is for three things: encapsulating security payload, authentication header, internet key exchange. That internet key exchange is again divided into two things: security association, key exchange. Now the last part we left over is key management. So for key management we have two different protocols: Oakley key determination protocol, internet security association and key management protocol. We have two different protocols for key management. So see here, we already spoke about authentication header. We already spoke about encapsulating security payload. Third one is internet key exchange. That internet key exchange is used for security association and key management. So see here. So for key management we have two different types of protocols. One is Oakley, nothing but Oakley key determination protocol. Second one is ISAKMP, Internet Security Association and Key Management Protocol. So first one, Oakley. See, we have Diffie-Hellman algorithm. Diffie-Hellman. So in unit 3, while talking about asymmetric encryption, in unit 3, while talking about asymmetric encryption, we have Diffie-Hellman algorithm. What are the drawbacks we have in Diffie-Hellman algorithm are overcome by Oakley key determination protocol. So for key exchange, we have two different protocols. First one is Oakley key determination protocol. What are the advantages of this Oakley? In third unit, while we are talking about asymmetric encryption, we have Diffie-Hellman key exchange. The drawbacks of Diffie-Hellman key exchange are sorted out in Oakley key determination protocol. So see here, what are the things we have in Diffie-Hellman? Secret keys are created only when needed. The exchange requires no pre-existing infrastructure other than agreement. So in Diffie-Hellman, secret key is generated only when it is required. These are the advantages of Diffie-Hellman. So two advantages we have in Diffie-Hellman. What are the two advantages? So secret key is generated only whenever needed. The exchange of keys is done with only just agreement. So these two are the advantages of Diffie-Hellman. So what are the disadvantages? Man in the middle attack is the disadvantage. It does not provide information about identity of the party. It is the disadvantage. Two advantages we have in Diffie-Hellman. Two disadvantages we have in Diffie-Hellman. So what are the advantages? Secret key is generated only whenever needed. Key exchange is happened based on the agreement only. So these two are the advantages of Diffie-Hellman. Same followed in Oakley key distribution also. Then what are the disadvantages? Man in the middle attack is one of the disadvantage. Not providing the information about parties, nothing but sender and receiver. Not providing the information about sender and receiver is the disadvantage. Man in the middle is the disadvantage. So Oakley will solve those both disadvantages. So first disadvantage is man in the middle attack. Second disadvantage is not revealing the identity of sender and receiver. So we know what is symmetric encryption, we know what is asymmetric encryption also. In asymmetric encryption, we are talking about RSA algorithm, Raven crypto systems, all those things. There only we have Diffie-Hellman key exchange algorithm also. This algorithm have two advantages, two disadvantages. So what are the two advantages of Diffie-Hellman? Secret key is generated only whenever required. Key exchange is happened with only agreement. So advantages are followed in Oakley key protocol also. Then what are the disadvantages? Man in the middle attack, you know already. Not revealing the information about sender and receiver. So these two disadvantages are overcome in Oakley key distribution protocol. So one more protocol is there that we will discuss in the next class. One more protocol we have. So if you see here, Internet Security Association and Key Management Protocol is there. Internet Security Association and Key Management Protocol. This protocol also used for key management. This we will see in the next class. So third point is key management. For key management we are using two different protocols. See, Oakley key determination protocol, Internet Security Association and Key Management Protocol. This Internet Security Association Key Management Protocol is simply called as ISAKMP. ISAKMP. So, we have encapsulating security payload, we have authentication header, we have internet key exchange. This internet key exchange is divided into security association and key management. So we have seen what is authentication header, what is encapsulating security payload, then what is key management. In key management, first one, Oakley key protocol, and second one. So see, what are the advantages and disadvantages in Diffie-Hellman key exchange? Disadvantages are overcome by Oakley key distribution. So then what are the features of Oakley? This Oakley has 5 important features. First one, it employs the mechanism known as cookies. The concept of cookies is used in Oakley. Second one, it enables the Diffie-Hellman key exchange. It will solve the Diffie-Hellman key exchange man in the middle attack. So it will exchange the public keys. So it will be against the replay attacks. So and finally, two parties will be in a exchange mode. So we have 5 different characteristics of Oakley. First one is the concept of cookies is used in Oakley. All the disadvantages in Diffie-Hellman are overcome. Concept of cookies are used. Simple. So all the disadvantages of Diffie-Hellman are overcome. Concept of cookies are used. These are the characteristics of Oakley. And finally, one more protocol for key management. Nothing but ISAKMP. ISAKMP is used to do authentication, confidentiality, integrity, everything. Internet Security Association and Key Management Protocol. It is the framework. It has some structure and it is used in network layer, it is used in transport layer, it is used to provide everything like authentication, integrity, confidentiality. So see here, it is of size 32 bits, means 0 to 31 bits. First, as I told you, the concept of cookies is used in these protocols. So first we are giving 32 bits for cookies and the 32 bits for cookies. Sender cookie, receiver cookie. So we have sender and receiver. Sender we are calling as initiator. Receiver we are calling as responder. So ISA-KMP is a protocol used for key management. It is of 32 bits. In that we are giving the place importance to cookies. So we have the sender cookie called as initiator, receiver cookie called as responder. We have message ID, we have flags, we have exchange IDs, we have versions, we have length also, we have payload also. So we'll see one by one. So first one, initiator cookie, nothing but sender, 64 bits. Responder cookie, nothing but receiver, 64 bits. Payload, 8 bits. Version, 4 bits. Major version 4 bits, minor version 4 bits. Payload, 8 bits. Exchange type, 8 bits. Flags, 8 bits. Message ID, 32 bits. Length, 32 bits. So what all we have? Major version, minor version. Next payload, message ID, length, exchange type, flags, initiator cookie, responder cookie. So we'll see what are the sizes. Length, the total length of the message, 32 bits. Message ID, 32 bits. Flags, 8 bits. Exchange type, whether you are exchanging manually or with connection or without connection, 8 bits. Major version, minor version, 4 bits each. Next payload, 8 bits. Responder cookie, nothing but receiver. Initiator cookie, nothing but sender, 64 bits. So flags is the concept you can see only in this protocol. So in ISA-KMP only you can see the flags. So what we have, length of the message 32 bits, ID of that message 32 bits, major version and minor version 4 bits, next payload 8 bits, exchange type 8 bits. Flags concept we have only in this protocol, we have the concept of flag 8 bits. So responder cookie and initiator cookies. So we'll see what we have discussed till now. So we have started unit 6. Unit 6 has 2 parts. One is IP security and one more is system security. So first we are discussing about IP security. So IP security overview, IP security features, IP security elements, IP security structure, applications of IP security, services of IP security, benefits, architecture. Finally 2 modes, tunnel mode and transport mode, authentication header, structure, encapsulating security payload, structure, key management. For that we have 2 protocols. First one, OCLAY protocol, OCLAY features. Second one, Internet Security Association and Key Management Protocol, ISA-KMP, structure and explanation. So by this, Unit 6 Part 1, Unit 6 first part, IP security completed. In the next class, we will discuss system security. Thank you.
Okay, madam.